Um, cool. And let's welcome our third lightning talk this afternoon. We're pretty good on time. We have good time management this afternoon. So we're happy to have Miss Tianqi Song. She is a PhD student at our department. She is advised by Professor E.J. Lee. So her study is on HCI. So very interesting. This is a best paper talk. Okay, so this paper was awarded the best paper at the AAAI multi-agent workshop. So the floor is yours.
Hello. Okay. Thanks, Ethan, for the introduction, and I didn't bring the trophy here. Good afternoon, everyone. My name is Tianqi, and I'm a PhD candidate at the NUS. And today, I really want to share our research about the multi-agent systems, but from a social intelligence perspective, is everyone here. So a little bit about the background. I think, as we all know, that multi-agent systems have been and is still a very hot topics in the of the AI research. And we can make the AI agents to coordinate with each other, divide tasks, and solve a very complex problems. I think earlier today, the Dr. Visha from Stanford University also shared their work about designing the multi-agent systems to be effective interview tools. But I think beyond the many current ongoing multi-agent studies, humans are still like very outside of the interaction loop. So we often treat the humans as just the supervisors or evaluators of the products that multi-agent generates. But what is less understood is that what happens when the humans actually interact with multi-agent systems directly. And you may wonder why people should do this. So, for example, in some very recent AI products, like the users can actually just interact with not only one agent, but multiple AI agents at the same time. So, for example, to receive multiple perspectives when making decisions. I think some of you might be like asking different AI models to get solutions at the same time with the belief that like two heads are better than one. And this is a question that motivates our work, which is what happens when multiple AI agents appear and act as a group, and how does that influence a human user's decisions? And our hypothesis also builds on a very core idea from the social psychology, which is people are often influenced by groups, especially under the uncertainty or when there is no clear right answer. And this is where we see some very classic effects like the conformity or herding effects. And this leads us to think about when the AI agents also appear as a groups, can they also create the group level social influence and how that change humans' decisions? So we asked three research questions based on the previous literatures and the hypothesis. And mainly we are curious about how the multi-agent AI may differ from the single agent AI in the human AI interaction. And moving from just the observed effect, we also want to understand about the underlying mechanism. So here is the interaction system we designed where the users can interact with the multi-agent in conversation group discussion settings, as you can see as a single screenshot. And we designed a between subject study where the participants can chat with either one, three, or five agents based on the two different social topics. So we choose some controversial social topics like the self-driving cars or violent video games. So there's no right or wrong answer about the topics they discuss. So very interesting about our finding is, so first thing that when discussing with the multi-agent, it actually leads to greater opinion change when all the agents are sharing the same stance. So as you can see, like in the screenshot, those in the five agent condition change their opinions, and also when the agents are having the same opinion as the users, it also leads to increased opinion, but more about the opinion polarization. So you think about like when the multiple agents agree with you, you're just more confident about yourself. So this still seems like a very intuitive result. So the next step is we want to unpack why this happens. And to answer this, we go to the social psychology literatures that shows us there are two underlying reasons of why people change their minds. The first reason is informational influence, which means you believe that the other groups are more likely to be correct, so you're persuaded. And another case is a normative influence, which is you don't know whether they are correct or wrong, but you want to conform. You just want to affiliate with a group. And guess what? Which one works here? Okay, so the result is actually the social pressure works here. So based on the surveys and the open-ended questions, most of the participants revealed that they didn't believe that the multi-agent are more likely to be correct, but still they conform just because they think they want to conform. And we can also see that there are some open-ended responses that we asked participants to describe what they feel. And I think this part is especially interesting. So you can see when the users write down, like they feel like they are an outsider of the AI agent groups, or like they are in the school clique that they wasn't part of. I think this highlight a very interesting nuance of our finding is we don't just affiliate with any groups, right? If it's like some puppies or a flock of birds, even they do something, we wouldn't feel like we want to follow them. But why it happens for the AI agents? So from these responses, I think it suggests that people will implicitly treat the AI agent groups as a social group that it can affiliate with. And this desire is a key mechanism that driving their conformity to them. And so, like, to summarize, so even if you know that you're talking to machines, you can still have the irrational feeling of being pressured. And I think some of you might be wondering, like, this just sounds like a very interesting human behavior experiment. And why is it relevant to the computer science and the AI agent? And the result is that AI agents is different from humans in the way that they can be deliberately coordinated and designed. So for human groups, when we know that there's social influence, it's just something that emerged naturally, but we cannot do anything about it. But for the AI agents, if I'm a hacker, I can immediately design some of the AI bots on the social media to spread the misinformation, and I can make the AI bots to agree with each other and press people. So this is not just a behavior question, but also a system design problem. And like, I think this is a very familiar example and also area that many of you are working on. So I think previously we just assumed that to mitigate the misinformation problem, we need to increase the transparency. We need to detect and make people know that they are talking with the AI accounts. But what I want to show here is that this is not enough. Even if we show it's machine, people still have the like irrational feelings. So we need to rethink about the possibility of the alignment our governments here. Yeah, and lastly, I want to mention something about the broader picture. So as humans, our intelligence is not just individual, and the evolutionary psychologists have highlighted that there's a relationship between the brain size and the typical social group size across the primate species. And like linking it to the AI agents and social groups here, I think the tendency that we humans might affiliate with AI agents and treat them as social actors, it has implications beyond just risk or manipulation, but it also opens up the possibility of viewing the multi-agent systems as some virtual social environments where humans can interact and grow with. So I just list this here, but I think the structure here is very similar to what Prof. Yang Di said in her human half of the problem in the slides. So I think these are the open problems and directions that we are currently working on to mitigate the problem. Oh, okay, so that's about our study, and here is a short takeaway. If we want to build a powerful multi-agent systems, we need to understand their social impact on humans, not only to avoid harm, but also to design the meaningful interaction and support human agency and collective intelligence. And that's all. Thank you.
Hi. Yeah, could I ask what the contexts were that you were applying this to? Like how do you set up the what kind of questions, what kind of tasks that you set up this social environment in?
I think like for this study, we like make it very simple group discussion scenarios. But I think this pictured a lot of scenarios. For example, the social media context, where you can just deploy a lot of the autonomous AI bots on them, and they can leave conversations with humans. And but I think for this like future aspects of the social environment, I think it's something that we should deliberately choose and build, like for example for education, for training. So like a thing that we've been pictured and built is like a workplace skill training problem where you can have multiple AI agents as your co-workers and train the undergraduate skills. So this will not be in the wild, but something that we need to carefully curate.
Yeah, I understand it, but what was your exact what was you had a group discussion, right?
Yes.
So what were they discussing?
Oh, they're discussing some social topics. So it's in this slides. So the topic one is about whether self-driving cars should be allowed on the roads, and the second topic is whether the violent games contribute to youth violence.
Okay, and basically it's one human, multiple agents.
Yes.
Okay, thanks.
Okay, thanks.
Great. Any more questions for Tianqi? If not, let's wrap up Tianqi's talk. Let's give her a few more hands. You ready? Yeah. Thank you. Okay, so our number 4 speaker is Miss Han Meng. So she is also a PhD student at our school, advised by Professor E.J. Lee.